Honky donkey. So today we will get the tools necessary to allow us to approach the quotient rule in a different way, or even better, if you don't like the quotient rule, it will allow you to avoid the quotient rule completely. However, before we get there, let's practice. Go, take the derivative of that bad boy. Whatever method you want, I don't care, just get the right answer. Get your first cut. What's up, Terry boy? Let me interrupt you. Do some calculus before you can get a picture.
Oh yeah, I got what you're saying.
I have this thing. Or wait, did I do something? No, I didn't. I did the same thing. What did you? Oh, you foiled the entire thing.
This is like a new vehicle.
Can we do that as well?
You can check. Check.
What? Thanks first. I didn't know. Yeah, I should probably go change.
Don't change. Stay wonderful person with you.
Okay.
I'm looking. 44. Where'd you get 44? I don't know.
Why does D over here?
I can see the bottom.
Is there actually?
I wasn't
How many are there?
You want small.
You want me on free kick, Judy?
I want him on free kick.
There should be two, but my division assistant stole the other one.
I'm gonna walk on
You're looking at the wrong side.
Wait, how do I write on it?
Whoa!
I don't know how to write on it.
Okay, hold on. That was my fault. I didn't talk you through it. Okay, so click on the left side of the board. Now go where it says that. Pick a color. Okay, now go crazy.
Okay.
She was a girl that never came to got her seat yet.
Listen to you.
Do the math on that one. How long ago was that? Oh, so do you have a calculator on?
Dorman. Yes, job.
Kayla, can I talk while you're working?
Yeah.
Excellent. So, the interesting thing about the way Kayla's doing it, which is not wrong, is she's just doing it backwards from the way I do it. That doesn't make, I don't know what just happened, but that was trippy. She's taking the first times the derivative of the second, plus the second times the derivative of the first. I do it the other way around, but it doesn't matter, it's a plus sign. A plus B is the same thing as B plus A. Okay, so far so good, I think. Yeah, okay, now we're distributing. Now we're combining like terms. we're asking how she did.
Good.
All right, let's give it up for Kayla. Okay, wait, no. Click on the pen thing again. Now literally click on the word pen, if you can reach it. There you go. Now stick the pen to the front of the board. Where there's a little pen, there you go. And grab some lumber, bub. Nice job. That means sit down.
Oh.
Have you never seen Breakfast Club? Okay. Yeah. He gets up to go get drinks for them and he goes, grab some lumber, bub.
We're uncultured. We're sorry.
It's okay. Before we move on, let's talk about the original function before we took the derivative is what degree?
4.
Yeah.
Yeah.
The original function that before we took the derivative of it is what degree? It's a fourth. And when we took the derivative of it, we end up with a third degree. We talked about that before, but you know, when you take a derivative, it drops the degree of the polynomial by 1. Great, let's move on. The chain rule. This one's huge. But let's talk about what we're going to do. We can now take, well, not now, soon we'll be able to take the derivative of composite functions. Now that's a little scary. We're going to do composite functions? Yes, but it'll be easy. Then today, unfortunately, we're going to have to start talking about how to simplify some of these functions. Come back to some trig stuff. Trig is fun. And you should be able to recite the state capitals. Springfield, good start. Boise, Albany,
Augusta,
Sacramento,
Trenton.
Jessica, what did you say? Tallahassee. What state is that? Florida. Florida, I knew that. Just see if you were paying. I don't know the state capitals. Just because I don't know doesn't mean you shouldn't. Okay, so let's start with this bad boy. You know how to take the derivative of this, yes? Okay, and what happens when you take the derivative of this is that it seems like you're wasting your time because we end up taking the derivative of this thing, this 1. So f prime of x is equal to 2x, denominator on the bottom, square it. Bring the denominator up to the top, multiply it by the derivative of the numerator, which is 0, minus big honk in bracket, the numerator times the derivative of the denominator. So I shouldn't have an x there, I should just have a 2 and then there, close the bracket, and done. Okay, now, the reason why that seems to be a lot of work is because, or maybe it doesn't, but this whole term is going to disappear because the numerator is a constant, and you know by now when you take the derivative of the numerator, it goes away. I personally do not like the quotient rule. It generates these ugly fractions and all this other stuff. So today, we're going to try something different. Can't I write this in the form of that?
Yes.
Right? That's the same thing. And because the numerator is a constant, it doesn't affect it. Let's suppose it wasn't a 1. What if it's a 5? Well, then it's just going to be 5 times the quantity 2x minus 7 raised to the negative first power. But all of a sudden doing that, I've created a composite function. I've got a function inside a function. Now, one of the things that's going to help you is to be able to recognize which function is inside which function. So which one's inside? Oh, okay, hold on. What are the two functions? 2x minus 7 is one of them.
and 1.
No.
X to the first.
To the negative first power, yeah. So it's an exponent to the negative first power. It seems like a silly question, but I'll ask anyways. Which function is inside? Okay, good. If you can do that, you'll be fine. Okay. So recognize those are two functions. 2x minus 7 is one of them. Raising something to the negative first power is the other function. Two functions. That's the big step. The second step is recognizing which one is inside. And you're gonna use that self-talk over and over again when using the chain rule. Okay. You also notice I haven't told you how to do that yet. We're gonna get to that later. Okay. Now, why? Well, do I need the chain rule for this? No, you already saw me take the derivative of that using what we know already with the quotient rule. It just gives you a different way to attack the problem. However, this bad boy, take what we did with Brooke, with the 3 functions multiplied together, and now multiply 10 functions together. Okay? It's probably after the 3rd or 4th that you start to cry and give up. So now we can use the chain rule to take the derivative of this bad boy. How many functions? 2. 2. Okay, which one's inside?
X squared minus 3x plus 7.
Beautiful. Okay, good. You're almost there. Now, how does the chain rule work? As I said, we're going to be taking the derivative of functions within functions. I'll come back to this example in a second. I want to talk about the actual function itself. Okay. But you've done the hard part. If you can recognize the number of functions that you have and which one is in the inside, you'll be great. Okay. So here are 2 examples, or 2 columns, I should say, of examples of things where you would need the chain rule and where you won't need the chain rule. Okay, obviously the left-hand column, which is titled without the chain rule, are all single function examples. When we get to the right-hand column, now all of a sudden we have functions within functions. And certain things happen, like you're probably going to get in the habit of writing this one this way. This one, I included that one purposely because I wanted to talk about the difference between this and this. Just to make sure we're on the same page, in the first one to the left, what's being squared? The x. In the left, or sorry, the right one?
The tangent of x.
Right. This is the same thing as the tangent of x quantity squared. Okay, just to make sure we're good to go there. Some of you might need a little refresher. Okay, I'm excited. Let's do some chain rule, shall we? Here it is. Now, we've already learned that a lot of times things in the maroon rectangles are written in gobbledygook. Okay, this might not mean a lot to you. I'll break it down for you in a second, but this is basically what you're doing. We have some function that's defined as a composite function. The composite function in the example is found by taking the derivative of the outside and chaining on the derivative of the inside. Okay, that's all this is saying. In fact, I put it there in English for you. Take the derivative of the outside function and chain on the derivative of the inside function. Okay so far? Beautiful. Let's go back to this example. All right, here we go. Which one's on the outside? I forget. To the 10th. Okay, so if I take the derivative of g prime of x, what's the derivative of some function, whatever you want to call it, raised to the 10th power?
X to the
Sorry? 10 something. 10 something to the 9th, right? Bring the exponent down and raise it to the 9th power. Okay, so what is that thing? Well, that something is this other function that we haven't touched yet. And then the chain rule says, multiply that by the derivative of the gunk inside. Okay, now here's where things get weird. And this is where some of you are going to cause problems. You're not going to stop. You're going to keep going. Okay, so now I'm going to chain on the derivative of 2x minus 3. Okay, now I'm going to chain on the derivative of 2. And what's eventually going to happen is we're going to get 0. So there's a rule for that. You chain on one less time than the number of functions. Okay. I think I have that up here somewhere. Oh no, I got to Shrek and Donkey first. I'll explain this in a second. Think of your function as being an onion. And what do you know about onions?
Layers.
They have layers, correct.
Yeah, there's a good reason Donkey shouldn't talk.
I don't get it, Shrek. Why don't you just pull some of that ogre stuff on him? You know, throttle him, lay siege to his fortress, grind his bones to make it bread. You know the whole ogre trick.
Oh, I know what. Maybe I could have decapitated an entire village and put their heads on a plate, got a knife, cut open their spleen and drink their fluids. Does that sound good to you?
No, not really, no.
For your information, there's a lot more to ogres than people think.
Example?
Example? Okay, ogres are like onions.
They stink?
Yes. No.
Or they make you cry?
No.
Oh, you leave them out in the sun, they get all brown, start sprouting little white heads.
No.
Which just an excuse to include a Shrek clip, which will probably get bounced off of YouTube for violations here. Okay, so let's go back to this guy. Whoops. You already told me there's two functions there. So again, it's one less. Two functions mean I chain once. Done. And that's actually the most common approach you're going to have. Will you have three functions and have to chain twice? Absolutely. But what you want to be sure to do is rein that in so you don't keep going beyond that. Okay. Derivative of the outside function chained on with the derivative of the function inside. By chaining on, I mean multiplying. Okay, does that make sense? We're good? Excellent.
Wait, so you don't have.
So you keep
So the
going?
answer was 10
Yeah, there's a-
times whatever to the 9 times 2x minus 3. That was the answer.
Yeah.
Oh. Okay.
Why, you want it to be more complicated?
No,
Oh,
I just didn't know.
And there's no way to simplify that either,
Yeah.
so we just leave it. Okay. What's the matter?
Didn't you say you have to keep going?
No, you don't keep going. That's what I want you to not do.
Oh.
Okay.
You said-
No. If you keep going, you're going to have some problems because you'll end up with 0. Doesn't matter. Yeah. Okay, so how many functions? 2. How many chains? 1. Good. What function is inside? What function is outside? Okay, good. Take the derivative. Don't worry about simplifying right now. Just take the derivative. So you see the two parts there. 2 functions, 1 chain.
Why is it?
I don't know, he's over it. He's right. He's right.
Yes.
Okay, we good? Done? Easy peasy? Yes? Okay, good. Should get that. Hey, by the way, -2 minus 1 is -3. Not negative. Who put a -1 in there? Okay. Feels good to confess, doesn't it? Cleansing of the soul.
I got it right.
Congratulations. Okay. Two functions. How many chains?
1.
Do it. It gets a little repetitive, but we'll pick it up as we get a little bit further. It's also not bad to continue to practice taking the derivative of polynomials. While you're working, quick question, what degree is h of x? What degree is h of x? It is a 16th degree equation. Well, there you go. Should have said it louder. I would give you full credit. Was that you, Nick? Yeah. Okay, we good? Easy peasy, yes? Yeah, there it is. Boom, done. Chain once. 2 functions, 1 chain. We'll skip that one. It's more of the same. I feel like we're beating a dead horse here. Or a dead donkey. Okay, now let's talk about some trig. Because you love trig, don't you? Yes, you do. Don't lie to me. This looks familiar from the other day. The only thing I did is I replaced x or theta with a u, and u represents some other function. So the only thing that changes when I take the derivative of sine u, I've got Gesundheit. There's two functions there. There's the sine function and there's the u function. You take the derivative of the sine function and get cosine of that function, and you chain on the derivative of that included function. Okay, so I wouldn't even, well, you have it in a slideshow, but I wouldn't even bother with this because it's just what you learned the other day with the basic trig function. You just got to remember to change. Okay, so here we go. How many functions? 2, 3. I'm sorry, what? What did you say?
I said, well, I don't know. It's like the square, and then you have like sine of something, and then you have the inside.
So you're saying 3. You are correct. Okay, wait. No, not yet. She's got one more question to answer before she gets an applause. What function is on the outside?
The square.
Okay, now we can clap for Abby. Well done. Oh, by the way, how many chains?
2.
Anybody? 2 chains. 2 chains? No, not a fan? Do you guys know who 2 chains is? Really?
Educate
I
us.
hate when jokes don't work because you don't know my references.
Wait, how do you determine how many like functions there are? Like that's what I'm confused.
Oh, good question. Abby, how do we know there's 3 functions there?
Okay, so you have the outside function is the square, because you're squaring like the sine, and then.
So, can I help out?
Yeah, go ahead.
What'd you call me? Did you call me a goat head? She did, didn't she?
She said, yeah, go ahead.
Oh, I'm sorry. My bad. Forget about what it is we're squaring. We're just taking something and we're squaring it. Back to you, Abby.
And then like the second inside of the square is the sine, because you're taking the sine of something, and then.
Okay, so we're taking.
Go ahead. Oh, sorry.
So then what are we squaring? We're squaring some function of sine.
Oh, okay. Because
Wrap it up, Abby.
And then inside the sine function is the square.
What are we taking the sine of that function?
okay.
Okay, so go back to when I asked you what functions on the outside was the squared function, which we need to know. Which one is the next layer of the onion?
Yeah.
Good, and then the inside of the onion?
Yeah.
Awesome. Okay, can you do this on your own?
Yeah.
Give it a shot, it's good for you, it builds character. Don't shake your head at me, man, you get this problem done.
Which one? Oh, he's dope. So the derivative,
Sine 4x 5 what the derivative? Sine 4x 5 must be like cosine. Just the order. Right? Right? What? No, remember the rule. The rule.
I did the rule.
Listen.
I did the rule. I did the rule.
Right. It's just wrong. Listen to me.
Why is it wrong? Why is it wrong? Why is it wrong?
You suck. I'll prove you wrong.
Whoa. These are some harsh fighting.
These are some fighting words.
How many 5 minutes could you take in a fight?
Of engagement are wrong.
How many 5 minutes could you take in a fight?
Billions. A quarter of
Not
quarters.
even that many 5 minutes.
So I'm good. So I'm safe. I will
How
never
many
be able
minutes could you
to.
take in a fight?
Probably not.
I don't know, did you?
Nathan, how many find minutes? 48. 48 and a half. So I can take more find minutes.
I have a sword.
Okay, there you go.
That is not my.
It's the sun.
Now, for those of you that didn't get that, let me explain how I did that. Based on what Abby told us, I took the derivative of a squared function. Taking the derivative of a squared function, bring the 2 down, reduce the exponent by 1. This first part is the derivative of the squared function. Then I chain on the derivative of the next layer of the onion. Just developed a stutter. The derivative of the sine function of something, we don't care what it is cosine. Cosine of that something. And then the last chain, because we're chaining twice, is a derivative of the inside function. Derivative of 4x to the 5th is 20x to the 4th.
Would you count like points off if we did like 2 bracket sine parentheses 4 and parentheses bracket and then bracket cosine parentheses? Like
You can slap all the brackets you want in there. You can go bracket crazy. No, it's not long. It depends on where you put the brackets. If you do something like this, yeah, I'm gonna take off some points because that's redonkulous.
What if you put brackets like starting from
No, I don't like
y?
what if questions. No.
What if I make the equation over 1?
This is an example of building. This is building on our arsenal of things that we've done already. How you attack derivatives from something simple as a constant function. That allows us to take the derivative of 2x cubed, for instance, when there's a constant out in front of it. Just take the derivative of x cubed, multiply by 2. Product and difference, sorry, not product and difference, sum and difference, product and quotient. And then today the chain rule, along with the smattering of the trig stuff in there, which you're going to come to hate, but is not as bad as you're going to make it out to be. As we progress further down this rabbit hole, we're going to start talking about what we need to do to simplify. Early on, since you're just taking a derivative, simplifying is not that crucial of a thing. Later on, knowing where we're going to go, we have to set that derivative equal to something and work with it. That's going to require a little bit more work, and that's probably the biggest challenge that you're going to have, and it's probably something that's frustrating many of you because your answers aren't matching the answer keys. And I know I talked about that, but that's okay right now. All right? Eventually, when we start doing the simplifying is going to take care of itself because in the process of simplifying, you're going to find other answers, and you won't be able to get the other answers if you can't simplify. So it'll come out in the wash. Okay. Now I've given you some buzz terms to remember when you're doing the chain rule so that you don't run off the rail and start doing crazy things like just keep chaining. How many functions? Which one's on the outside? How many chains? Okay, start from the outside and work your way into the center of the onion. We're done. Questions? No? Yes? I wasn't really in a band, it was just a joke. I cannot play it. I can't, well, I shouldn't say that.
Can you sing?
Oh, no. Trust me, you don't want to experience that. My kids are all musically inclined, but I can't play anything.
What did they play?
My son plays just about everything. You name it, he can play it.